Welcome to my algebra class. We're on chapter 12, section 5, and we're going to be solving quadratic formulas, and we're going to choose the best method of factoring them or solving them. We'll use the quadratic formula if it's in the form of ax squared plus bx plus c equals 0, and you have a calculator. We'll use factoring if it's in the form ax squared plus bx equals 0, or if it's a trinomial and you can easily find the factors. We'll use the property of square roots if it's ax squared plus a number equals 0. And we'll use completing the square if it's x squared, remember it has to be 1 in front, plus bx plus c equals 0, and b is even. So for the following, this one I would use the square, so it'd be 12x squared equals 108. Let's add the 108. Divide by 12, isolate the perfect square. So we get x squared equals 9. Take the square root of both sides, so x equals plus or minus 3. That's the easiest way to do that one. B, I would use the quadratic equation. So x equals the opposite of b plus or minus the square root of b squared minus 4ac over 2a. So that would be the opposite of b would be 12 plus or minus the square root of b squared, 144, minus 4 times c, which is 7, over 2 times a, which is 8. So that's 12 plus or minus the square root of 144 minus 56. Excuse me, that's 16 times 7. Where's my calculator at? That's 112. Over 8. So that'd be 12 plus or minus the square root of 32 over 8. And 32 has the perfect square 16 times 2. So it'd be 12 plus or minus 4 radical 2 over 8. And I could divide everything by 4 and get 3 plus or minus the square root of 2 over 2. And then if they ask me to rationalize to the nearest tenth or round, I can do that. C, this one I would factor. I'd take out a 4 and a t, and that leave me t, take out the greatest common factor, 4t, so that leave me t minus 14 equals 0. So 4t could equal 0, so t would be 0 here, and t minus 14 could equal 0, so that would be 14. And that's the easiest way to do that one. D, I would use completing the square because this is even and there's a 1 in front of that. So it'd be n squared plus 8n, move the 2 to the other side. Half of 8 is 4, squared is 16. Add that to both sides. And then the square root of n squared is n, the square root of 16 is 4, and that equals 18. Take the square root of both sides. So I get n plus 4 equals, and there's a perfect square of 9 in there, so 3 radical 2 plus or minus. So then subtract 4, n equals negative 4 plus or minus 3 radical 2. And then if I needed to round to the nearest tenth, I could work that out in my calculator. And the last one, that one's pretty easy to factor because the product is 12 and the sum is 7, and I can know immediately that the two numbers work are 4 and 3. So that's x plus 4 and x plus 3 equals 0. So my solution is negative 4 and negative 3 would work. So we're going to do problems where we're going to try and find the best method to solve the problem. So you have your book open to 577, and we're doing written 1 to 14. And the directions say solve each quadratic well, the first 12 problems, solve the quadratic form equations given in oral exercises 1 to 12, and then write the answer in simplest radical form. So number 2, we have x squared minus 2x equals 1. And I'm going to use completing the square on this one. So half of negative 2 is 1. 1 squared is 1. So I'm going to add that to both sides. Square root of x squared is x. The square root of 1 is 1, and that's minus in the middle, equals 2. Take the square root of both sides, and I get x minus 1 equals plus or minus the square root of 2. Add 1 to solve for x, so 1 plus or minus the square root of 2. So 1 plus the square root of 2 and 1 minus the square root of 2 will work, and using my calculator, 1 plus the square root of 2 to the nearest tenth Well, I'm sorry, they don't want us around, so we don't need to do that. Oh, goodbye, calculator. So that's our answer right here. And you could leave it in the short form too. Number 4, I have 8x squared plus 11x equals 0. This one, probably just factor. Pull out your greatest common factor, which is x, and you have 8x plus 11 left equals 0. So x could equal 0, and 8x plus 11 could equal 0. Remember the trick on this. I need a negative 11 plus 11 makes 0, but I gotta get rid of the 8, so I put negative 11 over 8. And there's my answer. Number 6, I have 3x squared minus 5x equals 4. So I'm going to make that set equal to 0. This one I use the quadratic formula. Here's A, here's B, and here's C. So it's x will equal the opposite of B plus or minus the square root of B squared minus 4AC over 2A. So the opposite of B would be 5 plus or minus the square root of B squared would be 5 squared is 25. Minus 4 times A, which is 3, times C, which is negative 4. All over 2A, and A was 3, so it'd be 6. So that's 5 plus or minus the square root of 25. Negative times negative is positive. And that's 16 times 3, which is 48, all over 6. So that's 5 plus or minus the square root of 73 over 6. And checking the answer for number 6, that's correct. Problem number 8, we have 2x squared plus 7x plus 3 equals 0. We could factor, although I think the quadratic equation is just as easy. So I'm going to use the quadratic. X equals the opposite of B plus or minus the square root of B squared minus 4AC over 2A. So that's the opposite of B, negative 7 plus or minus the square root of B squared, 49, minus 4 times A, 2 times C, 3, over 2 times A, which is 4. It's negative 7 plus or minus the square root of 49 minus 24 over 4. So that's negative 7 plus or minus the square root of 25 over 4. So negative 7 plus 5 over 4, and negative 7 minus 5 over 4. Negative 7 plus 5 is negative 2. So negative 2 fourths is negative 1/2. And negative 7 minus 5 is negative 12 over 4, which is negative 3. So my solution is, and checking the answer, negative 1/2 and negative 3. Problem number 10. We have the quantity x minus 2 squared equals 7. I would just take the square root of both sides. So we get x minus 2 equals plus or minus radical 7. Add 2, so we get x equals 2 plus or minus the square root of 7. And that's our solution for number 10. Number 12, we have 4x squared minus 2x minus 3 equals 0. Again, probably the quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4ac. And this is a, this is b, and this is c. So the opposite of b would be 2 plus or minus the square root of b squared, 4 minus 4 times a, 4 times c, negative 3. Whoops, I forgot the 2a. All over 2a, which is 2 times 4, which is 8. So that's 2 plus or minus the square root of 4 plus, because we got a negative times a negative, 48 over 8. So that's 2 plus or minus the square root of 52 over 8, and within the 52 is a 4 times 13, so I can take that out. So the square root of 4 is 2, so it's 2 plus or minus 2 radical 13 over 8. And the 2, 2, and 8 are all divisible by 2, so that's 1 plus or minus 1 radical 3, but I don't need to write the 1 over 4. And checking the answer, that is correct. And problem number 14. We have x squared minus 8x equals 11. I would use completing the square since the coefficient here is 1 and this is even. So half of 8 is 4. 4 squared is 16. So I add that to both sides. Square root of x squared is x. The square root of 16 is 4. And the middle term is negative, so it has to be minus 4. Add this up, I get 27. Now take the square root of both sides. I get x minus 4 equals plus or minus the square root of 27. Within 27 there's a 9, so I need to simplify that. So it's x minus 4 equals plus or minus 3 radical 3. Add the 4 to both sides to get the x by itself, so I get 4 plus or minus 3 radical 3. And checking the answer to number 14, that is correct. So that concludes the evens. Check your answer key in the back as you do the odds and make sure the